Good day, this is Professor Will, CBMD PhD. Today is Wednesday, July 17, 2019. It's 22:27:13 seconds Eastern Standard Time. And today I'm going to be doing a short study on systemic fungal infections. So let's hop to it here. Many other fungal species can cause invasive infections besides the more common systemic fungal infection. In Southeast Asia, penicillin marnifie is a major cause of invasive fungal infection in patients with advanced HIV infection. Paracoccidioides brasiliensis is a major fungal pathogen in some areas of South America. Paracoccidioides brasiliensis causes asymptomatic infection in normal individuals that can remain latent and disseminate if the immune system subsequently becomes impaired. Recently there have been several reports of systemic fungal infection with the Saccharomyces cerevisiae, which is commonly known as brewer's or baker's yeast. Although rare, these cases illustrate how a usual non-pathogenic organism can cause serious infection if it colonizes a susceptible host. Pseudolischieria boydii is a mold that causes severe infections in patients with prolonged neutropenia, or who are receiving a high dose of corticosteroid therapy. Pseudolischieria boydii infections are similar to those caused by Aspergillus sp. Sporothrix skinkii is a dimorphic fungus found in soils and plants that can cause sporotrichiosis after inoculation in the skin. Sporotrichiosis has been reported throughout the world, but is associated primarily with activities that result in exposure to plants such as gardening and farming. Mucormycosis is caused by a variety of fungal species with a complex taxonomy including Rhizopus obsidia and Mucora. In diabetic patients with poorly controlled hypoglycemia, mucormycosis is a devastating and often incurable infection. Pheohypomycosis is caused by a variety of fungal species that have dark cell walls. Cerebral pheohypomycosis is a rare but rapidly lethal brain infection that has been commonly associated with the fungus Cladosporium trichoides. Treatment and prevention of systemic fungal infections. Most systemic fungal infections are fatal without antifungal therapy. Unlike the situation for bacterial pathogens, the antibiotic arsenal against the fungi is small and consists of no more than half a dozen drugs. Since the late 1950s, amphotericin B has been the mainstay of therapy for many invasive mycoses. Amphotericin B is a powerful fungicidal agent that binds to fungal sterols and kills the fungal cell by disrupting cellular membranes. Amphotericin B may also have important immunomodulatory effects that could contribute to its therapeutical efficiency. Amphotericin B has significant toxicity that can be lessened by incorporating it into liposomal preparation, but these are significantly more expensive. In recent years, other agents that target the sterile metabolic pathways have been introduced, including fluconazole and itraconazole. These agents are usually fungostatic but are much less toxic than amphotericin B, and have the added advantages of being available in oral formulations. 5-fluorocytosin is another antifungal drug that is effective when used in combination with other antifungal drugs. Several antifungal agents are in preclinical and clinical development, and newer agents with enhanced efficiency and reduced toxicity may be available in the future. A major problem in the therapy of systemic fungal infections is that antifungal chemotherapy is less effective in the setting of defective immunity. For example, antifungal therapy cannot usually eradicate C. neoformans, H. capsulatum, and C. imitis infections in patients with advanced HIV infection. As a result, affected individuals must be given lifelong suppressive therapy to reduce the likelihood of clinical recurrence of infection. The difficulties associated with the therapy of systemic fungal infections have stimulated interest in immunotherapy, but the therapeutic strategy is still experimental. There are ongoing efforts to develop vaccines against coccidioidomycosis, histoplasmosis, and cryptococcosis, but none is currently available. At this time, the two main strategies for the prevention of systemic infection in patients at risk for infection include avoidance of infection and the use of prophylactic antifungal drugs. For many systemic fungal infections, prevention is difficult because the fungal pathogen is highly prevalent in the environment. For example, C. neoformans is found in high concentration of pigeon excrete in urban areas such as New York City, where many patients with advanced HIV infection live. Similarly, H. capsulatum and C. imitis are prevalent in soils of specific geographic areas of the world, and avoiding exposure may be difficult for residents in those regions. Nevertheless, it is prudent for individuals with immunological disorders to avoid sites likely to contain high concentrations of aerosolized fungal pathogens such as construction sites, aviaries, chicken farms, and compost sites. Prophylactic administration of antifungal drugs has been shown to reduce the incidence of certain fungal infections such as cryptococcosis in patients at high risk for infection. However, there are concerns that prophylactic drug use will encourage the selection of drug-resistant fungi, and drug prophylaxis is used routinely for the prevention of fungal infection. Another preventive strategy to reduce the invasive fungal infections in patients with neutropenia is to administer colony-stimulating factors that reduce the neutropenic interval by stimulating leukocyte production. Anaerobes, microbes that are capable of generating ATP without the use of oxygen, exhibit various degrees of oxygen sensitivity. Loxinous, non-indigenous, dormant, in transit, and not characteristic of the habitat. Autochthonous, indigenous, present during evolution of the host, and characteristic of the habitat. Cecum, the proximal blind portion of the hindgut. Colon, the mid portion of the hindgut. Competitive exclusion, the protective functions of normal flora of the gut to prevent entry of colonization of pathogen. Epimural bacteria, bacteria attached to the epithelial cells lining the gut. Foregut fermentation, microbial fermentation prior to the gastric and peptic digestion. Hindgut fermentation, microbial fermentation after the gastric or peptic digestion. Hydrogenosomes, cytoplasmic organelles present in anaerobic protozoa and fungi containing enzymes that produce hydrogen from oxidation of reduced cofactors. Normal flora, the population of microbes that normally reside in the host and for the most part live in harmony. Peristalsis, a wave of contraction followed by relaxation that propels the digesta down the gastrointestinal tract. Rumen, the largest of 4 compartments of the ruminant stomach inhabited by a myriad of microbes. Good day, this is Professor Will, CBMD PhD. Today's Thursday, July 18, 2019 is 0013, 23 seconds Eastern Standard Time. And this concludes my reading on fungi and fungal systemic infections. Hope you enjoyed listening. Have a great day.